Hi there. My project is focused on honeybees' memory, and my question is to compare the negative effect of two atmospheric pollutants, petrol exhaust pollution and insecticide, on honeybees' memory. I found that exhaust pollution has a more negative effect on honeybees' short-term memory when compared to the insecticide. However, it's the opposite when looking at the long-term effect. I found that the insecticide has a more negative effect on honeybees' long-term memory than the exhaust pollution. This is my main graph, and I found significant differences between the effect of exhaust pollution and insecticide on honeybees' memory across the three different time points: 1 hour, 24 hours, and 48 hours post-conditioning. I listed the time on the x-axis and the treatment effect on the y-axis, where the higher the bar, the better, or the lower, the worse. If we look at the 1 hour time point, we see that the exhaust pollution treatment effect is less than the insecticide, which shows that it has a more negative effect on short-term memory. I define short-term memory as being less than 24 hours, whereas the long-term memory as greater than or equal to 24 hours. And so if we look at the two 24 hours and 48 hours time points, there seems to be a flip where the insecticide has a more negative effect on memory than the exhaust pollution. So why do we care about this result? Bees rely on VOCs to find resources such as nectars and pollens. However, once we introduce the atmospheric pollutants such as petrol exhaust pollution and insecticide, they can mask the VOCs, making it harder for bees to track their trail, which ultimately affect their foraging efficiency. When we look at the graph, both exhaust pollution and the insecticide have negative effects on memory, meaning their treatment effect is less than 1. Therefore, policies related to bees conservation should not only focus on urban areas where we see lots of traffic-related pollution, but also on rural areas where the use of insecticide is prevalent. Moving on to my methods, this is my first dataset. It's the experiment using exhaust pollution. First, I averaged the PER of the different VOCs, and they're considered the control. I did the same thing for the polluted versions of the VOCs, and they're considered the treatment. Polluted here means that they were conditioned and exposed to carbon monoxide, nitric oxide, and nitrogen dioxide in concentrations you typically find near the roadside. I then calculated the treatment effect by dividing the treatment by the control. On my second source, I used a web digitizer to obtain the PER values from this graph over here, and I averaged all the three concentrations, 0.1, 0.5, and 1 micrograms of acetamiprid, which is a class of insecticide, and they're considered the treatment. Again, I calculated the treatment effect by dividing treatment by the control. And finally, I used a two-tailed t-test analysis, assuming equal variance, to analyze the data.